Hello everyone, my name is George and I'm a senior software engineer at Collabora, where I work on open source multimedia. In this talk I'm going to present Pipewire and WirePlumber, and I'm going to show you how you can use WirePlumber to manage streams in Pipewire. First, I'm going to start with a quick introduction to Pipewire and WirePlumber so that you have a basic idea of what I'm talking about. And then I will show you things in practice with a live demo. Let's start with Pipewire. You may have heard of Pipewire as an audio server, and you may be even using that in your desktop systems right now as an audio server. However, Pipewire is more than that. It is a powerful multimedia IPC framework that allows applications to transfer media to each other and to access devices in a secure manner and get media from those devices or send media to those devices. Media being audio, video, or anything else. With that ability as a base, it has the ability to implement audio servers, and it has all the functionality necessary to implement, to replace both professional audio servers like Jack and standard desktop servers like PulseAudio. It also implements things like Bluetooth audio that was previously only available in PulseAudio. And it has also the ability to implement equivalent video server functionality, so it allows you to share video content from your web camera or from your video capture device to applications in a safe manner. It has a built-in security framework that also allows applications to be accessing those devices in a safe manner, and it isolates applications to each other so that they cannot do harmful things to one another. And performance is really good. How this works internally is that all these applications and devices that are connecting to Pipewire, they represent themselves as objects that we call nodes. And these nodes are the basic building blocks of a multimedia pipeline. They can process the media internally. These nodes create input-output points that we call ports. Each port is able to send or receive one kind of media. And a node may have multiple ports, for example, to send different channels of audio to another processor or to a device. And these ports then get linked together. Ports from different nodes get linked together, and this forms a media graph. Configuring those nodes and ports and creating links between ports from different nodes is the job of a secondary process which we call the session manager. The session manager is responsible for orchestrating all this pipeline. In a picture, it looks like this. All these gray boxes are different processes, and we have in the middle we have the Pipewire process, which has all these little objects that I mentioned inside. All these green and purple boxes are nodes, and you can see how nodes on them, they have other boxes which are the ports, and the ports get linked together to ports from other nodes, and they form a media graph that allows media to flow from one node to the other. And then above you have the Pipewire Session Manager, which is another process that also connects to Pipewire as a client, and it has the ability to control this whole pipeline. Then we have other clients that are media playback or capture clients that present themselves as nodes, and you have also you may also have other things like the Wayland compositor that shares video content from the screen, and you also have all the devices available from ALSA, from Video for Linux, and the Bluetooth devices as well. They are all available in Pipewire as nodes. Now, WirePlumber is a modular session manager implementation for Pipewire. It has in the core, it provides an API that you can use to write any kind of tool that interacts with Pipewire. And on top of this API, we have built a daemon that is scriptable with Lua scripts. And in these Lua scripts, you can write some logic to tell WirePlumber what to do with your media pipeline. So you can write your own scripts and provide some logic to orchestrate the media pipeline. And I will show this right now with a demo. So I'm going to present a demo. First, I will show you two processes sharing audio between each other. So one process will be creating some audio and the other process will be consuming it. And then I will show you how we can also enable devices directly in Pipewire. I will show you an ALSA device and how we can send audio to this ALSA device and hear audio on the speakers. And finally, I will show you the security mechanism and how the security mechanism works in Pipewire. Here I have a virtual machine running Debian with the XFC desktop environment, and I have previously compiled and installed the latest versions of Pipewire and WirePlumber in the system. And I have started both using their systemd init scripts. So Pipewire and WirePlumber are here and running. I have let Pipewire run with its default configuration, while I have removed the logic from the WirePlumber default configuration. So I have edited the script in etc WirePlumber, wireplumber.conf. I have changed this script to not load any Lua scripts here in the WirePlumber components section. So for the WirePlumber library, I'm only loading the Lua scripting module that gives the WirePlumber library the ability to handle Lua scripts. But other than that, there is no Lua script loaded, so there is no logic predefined. And WirePlumber is effectively not doing anything. So for this demo, I'm going to show you how we can pass through media from one process to the other. And I'm going to demonstrate this with two GStreamer based pipelines. One of them is going to produce some audio and the other one is going to consume it. And we're going to see how we can get audio passed through from one process to the other. So I'm going to start two pipelines. The first one is going to be GStLaunch audio test source Pipewire sync. So audio test source is an element that generates some audio, and Pipewire sync is going to send this audio to Pipewire. I'm starting this one. And the other one is going to be Pipewire source to ALSA sync. So this one is going to retrieve data from Pipewire and send it to the ALSA sound card. So effectively we have audio routed from this place, from the audio test source, going through Pipewire to the other process and then being sent to the ALSA sound card. Now you can see that these two processes, they are not doing anything, they are paused effectively. These pipelines cannot start, and the reason is that these Pipewire elements, they are not communicating to each other internally. They connect to Pipewire and they create nodes in Pipewire. How do I know that we have nodes created? We can inspect that with pwcli ls. pwcli ls is going to show us all the objects that are currently registered in Pipewire. And some of these objects are going to be nodes, like this one that you see, it's a GST launch. I can also filter by the object type and only show the nodes here. So you can see there is one node from the first GST launch process and another node from the other GST launch process. And you will see that these nodes have some properties here. One of these properties is the media class property. For the first process, it's set to stream output audio. That means it's sending audio. And the other one is stream input audio. That means it's capturing audio. It's receiving audio as input. Now these nodes exist, but they don't have any ports. How do I know that? Well, I can filter by the port type, and we see that there is no port registered in Pipewire. That means these nodes have not been configured. The first step to this exercise is to configure the nodes. So we need to write some logic in WirePlumber to make these nodes be configured. For this reason, I have written this first script, this policy demo 1 Lua. And what this script is doing is, first of all, it registers an object that is called the object manager. The object manager is a helper object that allows the script to get a handle on the objects that it is interested in. So in this case, this script is interested in the nodes that have this stream something media class property. And this is how we declare this interest here. We are interested in type node with a constraint on the media class property that it must match the stream and / wildcard pattern. And we register that, and this object manager has some signals that notify us when events happen. So when new nodes are added or when nodes are removed, there are two signals that are being fired. One of them is the object added signal, and the other one is the object removed. And we connect those to some functions. Now, in the object added signal, essentially we get notified that a new such stream has been added. So that probably because the GST launch client was just started. And what we want to do here is we want to configure this node to have ports. Now, the easiest way to do that here is to create one of those helper items that we have in WirePlumber. For audio, it's called SI audio adapter. This is a WirePlumber specific object, which is provided by one of the WirePlumber's modules. And it has some logic internally that it wraps one node and configures its ports appropriately. So we are going to create this session item. This is the name of the class of this object, and we're going to activate it and register it. And when we do that, the ports are going to be configured automatically behind the scenes. Now, how do we load this file? We can go into the wireplumber.conf and insert a snippet here. So we are going to tell it to load this policy demo 1 Lua from the standard scripts directory, and we are also going to tell that it's a script /Lua. This is the type of this component. There are other types like module as well as config Lua, and it's something that is extensible actually. So we are loading this
policy demo 1 Lua. And there is one thing that we also need to load is the module that provides this item, this session item, because it's not part of the standard WirePlumber library, it's an extension as well. This one is a module, it's a native module, it's not a script. It's written in C, this object. So we provide this object factory and we provide the script, and we are ready to, after saving the file, we are ready to give it a go. We can restart WirePlumber with systemctl. I'm going to stop the processes first so that we don't have any issues. Now we have restarted WirePlumber. I can confirm it's running. So I'm going to create these again. And now still nothing happens, but this time I should be able to see some ports. And yes, I can see one port here. This port is the output port of the first GST launch process. This is the only one that gets configured to have a port, because this is the only one that is actually in this provide mode. The other one is considered to be a client that depends on the source, so there is some logic there that ports get created only when we try to link this node, so that the ports are created to match the number of channels that the source has. But the source here already has a fixed amount of channels. It has one channel, and we can tell Pipewire we can tell WirePlumber that it's that, and it creates the port and doesn't wait for anything. Now, the second step here is to create the links. How do we do that? Let me stop again. I'm going to try another script now, this policy demo 2 Lua, that is going to work in combination with the first one. So the first one is going to create these SI audio adapter objects, and the second one, it's going to also declare an object manager that is interested in SI linkable objects. SI linkable is an interface that is implemented by the SI audio adapter. So I'm going to filter WirePlumber's internal list of objects here for objects that are of type SI audio adapter effectively. And there is also again the object added and object removed signals. And I'm going to connect here the object added signal to a function that tries to find the target node for the node that it's operating on, and then it's going to create a link to that node. So this function is going to be called for both processes, both GST launch processes, because both are creating nodes and both are being wrapped in SI audio adapter objects. So this is going to be called twice, and there is some logic here to skip linking if it's already linked, because they are going to be linked to each other. So at least one of them is going to go into creating a link and finding the target first, and I'm going to find the target node by looking at all the other linkables. So I'm again looking at this linkables object manager which are created here, and I'm iterating over it to get access to all the other SI audio adapter objects that are available. And I'm going to match media classes. So if the first node's media class is stream input audio, I'm going to look for a stream output audio to link it to. if it's stream output audio, I'm going to look for a stream input audio. So always the opposites. And then I'm going to create a link. The link is being created in WirePlumber again by creating another session item, which is called a size standard link. And this is again, it's a session item, it's a wrapper around the Pipewire's native link objects. In this case, it's going to properly configure both nodes to have the appropriate number of ports, and it's also going to create the appropriate amount of links, because in the standard Pipewire setup we typically have one port per channel, and we have one link per channel as well. This happens automatically in this size standard link. So I need to load this. Again, it's going to be very similar. I'm going to load the second script, and I also need to load, of course, the SI standard link module. And now we can restart WirePlumber and try that again. And you see here, you see that it actually started playing something. It actually made a link. Now, audio wasn't perfect because these pipelines need further tuning to be able to work reliably, but this is out of scope for this demo. The important part to keep from here is that we managed to make a link, and we managed to get some media transferred from one process to the other, and we could hear some of it out in the speakers. Now, the next thing I want to show you is how to enable ALSA devices directly in Pipewire. In the previous example, we transferred audio from one process to another, and then this secondary process was responsible for opening the ALSA device and writing sound there. Now, in this next step, I'm going to enable the ALSA device internally in Pipewire so that we can transfer audio directly to the ALSA device through Pipewire. Doing that requires adding some more logic in our Lua scripts. Now, I have written this Lua script which starts the ALSA UDEV monitor, it's a Pipewire plugin which is provided with the standard Pipewire installation, and we can load it here with this SPA device object. We start it with its factory name, and it gets instantiated, and then it has a signal that notifies us when there is a new device discovered. So we have this function create device, which gets called every time there is a new device discovered, either because it's already in the system and we just started the monitor, or because it's a new sound card that was added later. Maybe a USB sound card that you just plugged in. Every time that you plug in your sound card, this function is going to be triggered. And in this function, the purpose is to create a device object, which is not a node, by the way. It's another kind of object that represents the device. And then this device object has another signal, again it's called create object, which lets us get notified every time the device wants to create some nodes. Now, the nodes in the device are not fixed, are not a standard number of nodes or a standard set of nodes, because the device can have multiple profiles. It can be, for example, it could be activated into analog stereo or analog duplex output and input modes, or it could be activated into the HDMI output or digital output and things like that. And in every of those different profiles, it provides a different set of nodes that actually open different devices in ALSA, or maybe the same device but with different properties. So every time we change the profile, this create node function gets called, and possibly multiple times, and creates a set of nodes. every node has its own set of properties, which is provided by the device factory. And here we move further along. We populate some of the properties of the node, like the node name and the node description, which are pretty much necessary to be able to see the nodes in a user-friendly way. And then we create this adapter object, which is a node. It's a Pipewire node with the properties that we have defined here, and we also got them from the device itself. Now, how this works in practice. So let's add it in our logic here, in our configuration file, sorry. So we save and we restart WirePlumber. And now, if we look at the objects, we are not going to see any nodes yet, but we are going to see a device which wasn't there before. So you see that this device actually has some description, user-friendly description, that was populated by the script right here. And it was set to be the same as the product name of the device. So yeah, this is the virtual sound card of this virtual machine. And it doesn't show any nodes because it doesn't have a profile yet activated. Now I'm going to show you another tool which comes with WirePlumber. It's called WP Control, WPCTL. This is a tool which is written using the WirePlumber API that I mentioned earlier. And it is used to inspect the status of the graph currently. So for this Pipewire instance, it shows which clients are currently connected, and then it shows which audio devices and nodes and video devices and nodes are present. In this case, we have this device presented here, and we can activate it by setting the profile of this device. 34 is the number of the object, the ID of the object, and I'm going to set the first profile. So if I look at the status again, now I'm going to see that it has a sink and a source. These two are nodes actually. I can go back into PWCLI ls node, and I'm going to see that these ones, 35 and 36, the same IDs that I saw here, these are nodes. One of them is audio sync, the other one is audio source. Now I could get this process, the playback pipeline, to link to that audio sync and play something, but there is no logic for that. The logic that we defined previously says if you have two processes with stream something, then link them together. It doesn't say anything about devices. So to get that to work, I need to modify a little bit the policy, the linking policy. First of all, I need to create session items for these nodes by declaring an additional interest here on audio media class, audio sync and audio source. And second, I need to go into the second script and try to match streams to audio devices instead of matching them to other streams. So an input stream is going to link to an audio / source, and an output stream it's going to link to an audio / sync. And by doing that and restarting WirePlumber, now I need to enable the device again. Now it plays something, and Now you see that this gets linked to the audio device and plays something actually, because the logic is such so that streams now are getting linked to two devices instead of to one another. So you can see how flexible this Lua scripting is. You can make anything link to anything else, and by changing a few lines of code, you can change the behavior of your Pipewire setup. Now, the next thing that I want to show you is the integrated security mechanism of Pipewire. To demonstrate that, I'm going to start a container, and I'm going to run some tools in the container and try to make them isolated so that they only see what I want them to see. I'm going to use Podman as the container runtime. Podman is a Docker replacement. If you don't know it, it behaves exactly like Docker. And I have previously built an image called Debian Pipewire here, which is based on Debian stable, and I have the only thing I have added there is the Pipewire and WirePlumber builds that I built myself. So I'm going to start it, and I'm going to pass through the Pipewire socket from the host so that it's directly available to the tools in the container. And the container has these tools available like PWCLI. Now, in order to be able to find the socket, I need to export this environment variable, Pipewire runtime dir, so that they can actually find the socket. And now you see that it works, and wpctl status is also going to work, and it shows exactly what it was showing in the host. To compare, wpctl status on the host, and it's the same exactly thing. Now I want this process in the container to be isolated. I don't want this to work actually. I don't want these processes to have permission to change my devices, and like I could probably set profile here to this device, and it would affect the host, but I don't want that. How do we fix that? First of all, we need to change Pipewire's configuration, which we didn't touch so far. So I'm going to this etc Pipewire directory, and it has nothing inside by default because all the configuration is in usr share Pipewire. Now I want to modify this pipewire.conf, and to modify it I can copy it to etc Pipewire. So now I have it here, and I'm going to go to the editor and I'm going to open it. And it's a long file, it has a lot of stuff going on. What I'm interested in is the configuration of this module access. Module access is a Pipewire module that checks all the processes from the clients that connect to Pipewire, and it allows them or rejects them based on the binary that the process is started from. So here I'm going to allow access to WirePlumber, which is our session manager, and I want this to be always allowed. And for everything else, I'm going to restrict access. Now, by enabling that configuration, I'm effectively blocking every process from connecting except WirePlumber. I'm restarting Pipewire now, and I'm going to demonstrate that PWCLI ls no longer works because it doesn't get access to Pipewire. It is in restricted mode. Only WirePlumber has access at this point. Next thing I want to do is I want to add some logic in WirePlumber to allow or not allow certain clients to connect. Instead of listing all these things here, which is a bit limited because it only checks the process paths, I will write a Lua script I have actually already written it here. And this Lua script works like that. So it listens for client objects. It declares interest in client objects. And these client objects, when clients connect, these client objects appear. And this function is going to be called. And here I'm going to check the properties of this client. And I'm going to look at this application process host property, which is going to be different on the host system and different in the container system. So I'm going to check if properties of the client, if the application process host of the client equals the host name of WirePlumber's core. This core is a handle to WirePlumber's main object, the core object, which is a global object that is available to all scripts. And I can inspect at which host is WirePlumber running, and I can compare it to the host that the client is running. And if they are the same, then I'm going to update permissions for the client, and I'm going to say I'm granting any object RWXM access. These RWXM are pretty similar to the permission bits that we have on the file system, where basically they mean read, write, execute, and M means metadata. It's a special permission bit. So for every object, Pipewire has a set of permission bits. If R is set, then the client is allowed to look at this object. The object is visible to the client. If W is set, then the client is able to send data, send media to that object. If X is set, then the client is allowed to execute methods on that object. And if M is set, then the client is allowed to set metadata for that object. We can play with combinations of that if we want, but for demonstration purposes, I'm going to keep it simple. And what I'm going to do is I'm going to allow clients that are running on the host are going to be granted full permissions for any object. And all other clients which are running in the container, I'm going to grant full access, but only to the object with ID 0, which is the Pipewire core object. So that means that the clients running in the container, they will only see the Pipewire core object and they would not see anything else. Let's see how this works. I'm going to add it. So adding it to the configuration, and then I'm going to restart WirePlumber. Now I'm going to try and look at the status, and I see that status works. pwclils also works, that previously didn't work. So that means that our script is working. It grants access to the processes that are running on the same host as WirePlumber. Now, if I go to the container and try the same thing, now you see that the devices are gone, the sinks and sources are gone, and the clients are gone. That means that the client running in the container is not able to see those objects. Actually, if I list the objects that are visible, we can see that only the object with ID 0 is visible. That is only the Pipewire core object. And this is exactly what our logic specified here. We said only object 0 should be visible, and everything else is hidden.
So I hope that now you have a better understanding of Pipewire and WirePlumber and how they work together. Thank you very much for watching.